Okay, geometry students, in this video we will be looking at yet again more angles that come in pairs. We will be looking at two different types of pairs of angles with more of these to come, dealing with angles that are in sets of two. There'll be more of these to come in the future in chapter 3. Okay, and here we go. Go ahead and copy this heading down your notes if you would please. Your heading today is vertical angles and linear pairs. So there's the two types of angles we'll be looking at, or two different types of sets of angles that we'll be looking at today. Vertical angles and linear pairs, lesson 2.4, and also include today's date, please. Go ahead and copy all this down. I'll pause just a second. Copy this in your notes, please. Vertical angles and linear pairs, lesson 2.4, and include today's date. Okay, moving on. Now, usually, don't copy this down, just listen. Usually, I will demand that we learn both the formal word definition of a term and what it looks like. But for these two terms, vertical angles and linear pairs, I feel that it's best to just understand what they look like. So, in other words, I am not going to give you a formal word definition, which most students are glad when I do this because it is less memorization for them. Let's start off by learning what vertical angles are. Now please take some really good notes. Again, I'm not going to give you a word definition. I'm just going to give you a picture of what vertical angles are. So here we go. Get your pens ready, pencils ready. Let's take some really good notes. I want you to draw a line that looks something like this, please. And then draw a line that looks something like this, okay? And here's what here's what vertical angles are. Again, please take some really good notes. Let's go ahead and put an angle 1 here, that we're going to call that angle 1. We're going to call that angle 2. We're going to call this bottom angle angle 3. We're going to call this angle to the left angle 4. Now please take notes on this. Please listen well. Watch this, students. Please watch carefully. Whenever two lines intersect, like this line here intersected this line here, obviously four angles are going to be formed. 1, 2, 3, 4. Well, vertical angles are when two lines intersect. So first of all, you have to have two lines intersect, but they're the angles that are across from each other. So we would write angles 1 and 3. I'm going to put VA for vertical angles, are vertical angles. And angles 2 and 4 are vertical angles. Isn't that easy? See how these two angles 1 and 3 are across from each other? Then they're vertical angles. Do you see how 2 and 4 are across from each other? Then they're vertical angles. Now I can't make it any easier than that. So vertical angles are when you have two lines that intersect, and they're the angles that are across from each other. Okay? Those are vertical angles. Next, let's take a look at what a linear pair is. Now again, take really good notes. I'm not going to give you a word definition, just a picture of what vertical angles are. So take some really good notes so that you're not confused. Once again, I want you to draw another set. Let's go back to this previous example here. Somewhere, I guess I probably should have spelled out the words vertical angles. Make sure you know what this stands for right here in your notes. Okay, it's very important that you understand that. Okay, go ahead and draw two more intersecting lines. Let's go ahead and number our angles again. 1, 2, 3, and 4. Now if I'm going too fast, just tell the supervising teacher to pause the video, okay? I go fast on purpose, expecting you guys to pause the video when necessary. So go ahead and draw two intersecting lines again, and go ahead and write in angles 1, 2, 3, and 4. Now, here's what a linear pair is. It's when you have a straight line, like this red line here, and then you have a line coming off of it, like this. So these two angles here are linear pairs. Now you might be saying, well, Mr. Earhart, do you have to have two lines intersect like you do for vertical angles? No, you really don't actually. You could have a line like this, and then a line coming off of it, and this angle here, we'll put a dot here, and this angle here with two dots, they would be a linear pair. Are you seeing it okay? A linear pair is any time you have a straight line and then a line coming off of it. Those two angles that are formed are always called a linear pair. Okay, not too difficult to understand. So going back to this original diagram here, it looks like 1 and 4. Let's write this down, students, okay? Angles 1 and 4 are a linear pair. All right, I'm going to quickly copy that so I have that. Okay, there we go. So angles 1 and 4 are linear pairs. Also, angles 1 and 2, right? Look, here's a straight line, and here's a line coming off of it. Angles 1 and 2 are side by side. So we could also say that angles 1 and 2 are a linear pair. And that's not working very well, is it, students? Sorry to waste your time. Hold on one second. There we go. Angles 1 and 2 are a linear pair. Look at angles 2 and 3. Here's a line here, and then this line coming off. So angles 2 and 3 are a linear pair. Angles 2 and 3, I'm going to use ditto marks, are a linear pair. And then here's a straight line here with a line coming off right here. Angles 3 and 4 would be a linear pair. All right, so angles 3 and 4 are a linear pair. So to sum this up again, students, anytime that you have a straight line like this with another line coming off of it, these two angles here and here are linear pairs. Okay, you do need to understand that because we're going to learn something else about linear pairs here in just a couple minutes. All right, okay, moving on. Now I would like you to take a second. I'm going to pause for about 30 seconds. I want you to copy down these three figures. Okay, just copy down this figure here, angles 1 and 2. Copy down this figure here, and I know the figures are a little blurry today. Angles 1 and 2. These two angles are angles 3 and 4, and these two angles here are angles 5 and 6. Okay, I'm going to pause about 30 seconds. Go ahead and copy these three figures down, and then let's categorize each of these into either vertical angles or linear pairs or neither. Okay, copy down these three figures, please. And then let's label each one of these either linear pair, vertical angles, or neither. Okay? All right, here we go. Let's take a look at letter A. Now, please follow along. Take some really good notes. You should see this right away, students. We have a line right here, and off of that line is coming another line right here. So anytime you have a straight line with another line coming off of it, these two angles that are side by side are called linear pairs. So in this example right here, angles 1 and 2, please take notes on this, students, are called a linear pair. Now, look at letter B. You might think, oh, I know the answer to this. They're vertical angles. No, you don't have two lines that are intersecting. You have one line here, and then you have this bent, crooked thing that's not a line at all. It's like this, and then it hits here, and it goes this direction. Remember what I taught you. In order to have vertical angles, you must have two lines that intersect. You have one line here. You do not have a line here. This is a strange, bent-looking shape that is not a line. So this here, angles 3 and 4 are neither. They're definitely not a linear pair, and they're definitely not vertical angles. Okay. Now, angles 5 and 6 down here are, in my opinion, obvious, and they are called vertical angles. And here's how I know that. I have a line here intersecting a line here, so I have two lines that are intersecting, and these two angles are across from each other, so they are called vertical angles. You really need to know this, or you will be lost later on this class period. So if any of you need to ask questions, please feel free to do so now. All right, I'm going to continue on. Now, one of these new terms that we just learned, linear pair, lends itself to a very simple postulate that you need to know. Here it is. You need to have this memorized, students. Please copy this in your notes. I'll wait just a minute while you do that. Postulate 7, if two angles form a linear pair, then they are supplementary, always. So if two angles form a linear pair, we know for sure they're supplementary. Okay, take a second and copy that down, please. If two angles form a linear pair, then those two angles are supplementary. All right, and here we go. In your notes, please, I want you to get a picture of this postulate. Go ahead and draw a line like this, and then go ahead and draw another line coming off of it like this. If you would, please. Thank you. And let's go ahead and put a 1 and a 2. Okay? Now write this down, please. Angles 1 and 2 are what? What are they, students? You should know they're a linear pair. So as soon as I tell you that angles 1 and 2 are a linear pair, then we can say, thus, they are supplementary. Okay? By the way, what's that mean? That means if you take angle 1 plus angle 2, you might want to write this down, you're going to get 180 degrees. So again, if two angles form a linear pair, then those two angles are supplementary. They will add up to, or they will have a sum of 180 degrees. Okay, moving on. Now, with this in mind, let's try our first math problem of the day. So please copy this problem in your notes if you would, please. I want you to write down the words, find the measure of angle RSU. That's what that phrase means. It means the measure of angle RSU. So find the measure of angle RSU, and then copy this diagram in your notes if you would, please. Copy that down, all right? Now, while you're copying all this information down, let me go ahead and take my pen here and show you where angle RSU is. Here's R, then over to S, and then up to U. So we're trying to find this angle right here. We're trying to find the measure of that angle. So I'm going to put a question mark there. And then please notice something, students. You should notice right away, and you had better get used to doing this, that you have a linear pair. You should see right away that you have a straight line here. And then off of that straight line, you have another line that's coming up like this, or a ray, whatever you want to call it, or a segment. So you have a straight line. And then right off of that straight line, you have another ray coming up. So this angle here and this angle here form a linear pair. Now, if they form a linear pair, we just had a postulate that told us when two angles form a linear pair, they are supplementary. So I know I can take 180 degrees and subtract 62 degrees, and I will get 118 degrees, and that's the measure of this angle right here. Because 118 plus 62 equals 180. So there we go. I mean, just not too difficult at all. All right. Now, students, I can't really make this much harder than it is. This is pretty simple math. I'm going to give you another problem, identical to the last one, and I want you to do this one on your own. Okay. So I'm going to go ahead and put the problem up. Do not pause the video. I'm just going to be really quiet for about a minute, let you guys work on this, and then I'll work it out for you and make sure you got it right. Here's the problem. Find the measure of angle FDC. And I'm afraid some of you can't read this, so I'm going to go ahead and make it real big. Sorry about that. 107 degrees, and this is C, and this is D, and this is, I'm not sure, we'll call it an O, and this is an F right here. Okay, there we go. I know some of the pictures are a little blurry today, and I apologize for that. 107 degrees. I want you to find the measure of angle FDC. Find the measure of angle FDC. Okay. Now hopefully you're finishing up. Let me show you a couple of things while you're finishing up. We're trying to find the measure of angle FDC. So here's F, down to D, and then over to C. So angle FDC. So here's the angle right here I'm looking for. Okay? Now right away you should notice that we have a linear pair. I mean, right away you should see we have a straight line. It's not bent or anything. And then a line or a ray coming off of it. So anytime you have a straight line with another line coming off of it, this angle here and this angle here are always going to be linear pairs, as long as this is a straight line right here. And if they're a linear pair, then they're supplementary. So I know these two angles, when you add them together, are going to equal 180 degrees. So I'm simply going to take 180 minus 107 degrees, and I will get 73 degrees. Okay, so this angle right here is 73 degrees, because if you add these two angles together, you will get 180. All right, let me get a drink here and we'll continue on. Okay, now the other term that we looked at earlier today, vertical angles, now it lends itself to a theorem. So we looked at linear pairs earlier, and they lent themselves to a postulate, okay? Well, the vertical angle term that we looked at earlier today, it lends itself to a theorem. And here's the theorem right here, okay? Here it is. Please copy this in your notes. Theorem 2.3, vertical angles are congruent. I'll give you just a second to copy that down. Vertical angles are congruent, theorem 2.3. Please copy that in your notes. Vertical angles are congruent. While you are copying that down, I also want you to copy this diagram in your notes. Go ahead and very quickly draw a figure like this, please, if you would, and put a 1 here and put a 2 here. Please copy this in your notes. And then off to the side, I want you to put angles 1 and 2 are vertical, comma, thus angle 1 is congruent to angle 2. There you go. If two angles are vertical angles, if you have vertical angles, they are congruent. So I'm telling you angles 1 and 2 are vertical, which they are. Thus we know angles 1 and 2 are congruent. It's that easy, students. If you have a linear pair, they are not congruent. Students get these confused all the time. They are not congruent. They are supplementary. If two angles are vertical, then they are congruent. You need to know this. All right. Okay, let's just quickly prove this. It'll be an informal proof, but I do want you to take notes on this. It would be totally fair for me to ask you to prove theorem 2.3 on a test. So we're going to prove this theorem. So take some really good notes, please. Somewhere in your notes, make a note saying something like proving theorem 2.3. Like off to the side over here. Proving theorem 2.3, and then draw an arrow, okay? Proving theorem 2.3. Okay, now instead of putting angle numbers like angle 1, angle 2, angle 3, I'm going to do something else, okay? I guess we'll go ahead and do that. We're going to go ahead and put angle 1, that'd be okay. Put angle 2 here, and put an angle 3 here, okay? Now here's what I want to show you, okay? Watch this so carefully. I'm going to prove that angles 1 and 3 are congruent, because they're vertical, right? Angle 1, angle 3, they're across from each other, they're vertical angles. I'm going to prove they're congruent, and I want you to take notes on this. The first thing you would write down is you would say angles 1 and 2, comma, write this down please, and angles 2 and 3 are what? What are they? They are a linear pair, aren't they? Sure they are. Angles 1 and 2 are a linear pair, and angles 2 and 3 are a linear pair. So the next thing you're going to write is this. Angles 1 and 2 are what? Remember we just learned our postulate. If two angles are a linear pair, then they're supplementary, right? It's back here somewhere. We just learned that, okay? If two angles are a linear pair, then they're supplementary. So if angles 1 and 2 are a linear pair, which they are, then they're supplementary. And I can also write down angles 2 and 3 are what? Supplementary. And now, what could you write next? Students, listen to me. Do you remember yesterday's theorem we looked at? We learned a theorem yesterday that said if two angles are supplementary to the same angle, then they're congruent. Do you remember that? We learned it yesterday. If two angles are supplementary to the same angle, then they're congruent. Well, look at angle 1. Angle 1 is supplementary to what angle? 2. Look at angle 3. Angle 3 is supplementary to what angle? 2. So angles 1 and 3 are supplementary to the same angle. Angles 1 and 3 are supplementary to angle 2. So next I can state angle 1 is congruent to angle 3. Now, a couple of you, maybe about a third of the class understood this. Maybe about a half or 2/3 of the class didn't. But you know what you can all do? All of you can memorize this and give it back to me on a test. If I ask you on a test to prove theorem 2.3, all of you can do that. So make sure you're familiar with this and make sure you know how to prove theorem 2.3. Okay, so let's look at it again. Theorem 2.3, vertical angles are congruent. So if two angles are vertical, then they will be congruent. Okay, let's finish up with some math problems and we'll be done for the class period. Now let's apply this theorem to a problem. Here we go. Copy this in your notes, please. Okay, find the measure of angle 1. That's going to be hard to do since we don't have a 1. So let's see if we can't fix that real quick. Sorry about that. It's a trick question. Let's go ahead and make this 2 a 1 here. Okay, now let's find the measure of angle 1. Well, right away, students, if you've been listening at all, I'm not being mean, but if you've been listening at all, you should see we have a line here that's intersecting this line here. And whenever two lines intersect, the angles that are across from each other are called vertical angles. And we just learned a theorem that said all vertical angles are congruent. So if all of that is true, which it is, then if this angle here is 50 degrees, then the measure of angle 1 would also be what? 50 degrees, because these two angles here, here, and here are vertical angles, and vertical angles are congruent. Okay? Now let's try a problem that ties both the postulate and theorem together in one problem. This will be very interesting, so please take some really good notes. All right, here we go. Copy this in your notes. And in case you can't read it, I apologize. Look at this carefully. This is angle 1 right here. And this is angle 2 right here. This is angle 3 right here. And this is angle 30. This is 35 degrees. 35 degrees, and I do apologize for the quality of some of these pictures. 35 degrees. Now, our goal in this problem is to find the measure of three angles. We want to find the measure of angle 1, we want to find the measure of angle 2, and we want to find the measure of angle 3. Okay? Well, this really isn't too hard if you think about it, students. First of all, you should notice right off the bat we have two lines that are intersecting. Here's one line here, and here's one line here. So whenever two lines intersect, we know right away that the angles across from each other, like these two right here, this angle and this angle, are vertical angles. And we just learned a second ago a theorem that said vertical angles are congruent. So this angle here, 35 degrees, and this angle here, angle number 2, have to be congruent. So angle number 2 is going to measure 35 degrees. Now, you should notice something else, students, okay? Notice how I have a straight line right here with a ray coming off of it. Okay, that means this angle here and this angle here are linear pairs. They're linear pairs. So we learned a postulate that said if two angles are a linear pair, or if angles form a linear pair, then they are supplementary. So this angle here and this angle here have to add up to 180. So I'm going to take 180 degrees and I'm going to subtract out 35 degrees. And I'm going to get 145 degrees. So this angle right here, angle number 1, has to be 145 degrees because this plus this has to add up to 108 degrees. So the measure of angle 1 is 145 degrees. And now look at this. Here's my one line. Here's my other line. They're intersecting. And remember, angles that are across from each other are always vertical, and so vertical angles are congruent. So if this angle right here is 145 degrees, then this angle here, which these two angles are vertical, they're congruent. Angle 3 has to be 145 degrees. There we go. Not too bad. Okay? Now, we have the exact same type of problem again. I want you students to try this one on your own, okay? So I do want you to pause the video this time, so go ahead and pause the video. I want all of you to work on this, and then when you're done, or whenever the supervising teacher feels like it's appropriate, go ahead and turn the video back on, and we'll see how you guys did. In case you can't make these out, and again, I apologize for them being blurry. This is 1, this is 2, this is 3, and this right here is 28 degrees. Okay, go ahead and pause the video and try this. Okay, students, hopefully everyone's done. Let's go ahead and take a look at this. First of all, notice we have two lines right here that are intersecting. So we know that this angle here across from this angle here are vertical angles, and we know that vertical angles are congruent. Okay, so we're going to find that the measure of angle 2 equals 28 degrees. Now let's continue on. Notice I'm going to go ahead and put a 28 right here real quick. So we're going to call this right here 28 degrees. Now, notice I have a straight line right here with a ray coming off of it, okay? Well, that means these two angles here are what we call a linear pair, and so they're supplementary, okay? So this angle here and this angle here have to add up to 180. So I'm going to take 180 and subtract 28, and I will get 152 degrees, all right? So this angle right here is 152 degrees. So the measure of angle 1 equals 152 degrees. And then students, look at this. We know these two angles here are congruent, so the measure, because they're vertical angles, we know they're vertical, so they're congruent. So the measure of angle 3 is 152 degrees. Okay? All right, let's move on to a couple more problems and we're finished. Let's finish the video with two algebra types of problems, okay? Two algebra types of problems. So here they are. Go ahead and copy this in your notes. You can work ahead or watch me, whatever you would like to do. We have 4y minus 42, and then over here we have 26 degrees, okay? We're going to solve for y. I'll pause a second here while you copy this down. Let's find the value of y, okay? Find the value of y. Okay, a couple more seconds. Quickly copy this down. You can work ahead or watch me. Now look, this is a straight line. This is a straight line. Whenever you have two lines that are intersecting, the angles that are across from each other are called vertical angles. They are congruent. So if they're congruent, then why could I not take 4y minus 42 and set it equal to 26? I can do that. And now let's solve for y, okay? So this is a negative 42. I'm going to bring it up. I'm going to pick it up and put it over here. And when I switch sides, it becomes a positive 42. So now it's gone. I'm left with 4y equals 68. And now I'm going to divide both sides by 4. And let's see if I do that correctly. I will get 117, I believe. Okay? Let's see if that's right. 28. Yeah, that's right. So y equals 17. There we go. Really not too difficult. I knew that I could set 4y minus 42 equal to 26 because these two angles are congruent. So if they're congruent, set them equal to each other. Now, what about if we're dealing with a linear pair? So copy this problem in your notes. Last problem, we're done for the video, okay? What about this problem here? What if we're trying to find the value of t? All right, so here we go. Notice I have a straight line right here, students. Do you see that? With a ray coming off of it. Do you see that? Well, whenever you have a straight line with another ray coming off of it like this, we know these two angles are called a linear pair. And listen, students, that means those two angles are not congruent. They add up to 180 degrees. These two angles add up to 180 degrees. So I'm going to put 20t plus 5, that's one angle, plus the other angle, which is 15t, and that should equal 180 degrees. Should it not? I mean, these two angles are a linear pair, and we learned a postulate today that said if two angles form a linear pair, they are supplementary. So I'm going to add the two angles together and set them equal to 180. Now, we can simplify the left side. We have a t term right here, and we have a t term right here. Let's go ahead and combine those. We have a 20t and a 15t. And there it goes, wasn't working. A 20t and a 15t would be a 35t. So I'm going to cross those off. I've combined those two. Bring down your positive 5 and bring down your 180. Now next, if I'm trying to get t by itself, which I am, let's bring this 5 over and make it a negative 5. Okay? So now the 5 is gone and I'm left with 35t equals 175. Okay? And now let's go ahead and divide both sides by 35. And I think 35 goes into 175 5 times, I believe. Let me see if that's right real quick. 35 times 5, 25. Yes, 175. So divide both sides by 35. These cancel out and t equals 5. Okay? And students, that's it. We're learning more and more different pairs of angles. We learned the other day about supplementary and complementary angles. And now they both came in sets of 2 or pairs of 2. And now today we learned what vertical angles are and what linear pairs are. And notice both of those also come in sets of 2 or pairs of 2. Okay, I hope this is going well. If you have any questions, don't hesitate to call or email.